Am I audible? Am I audible or not?
Audible, sir.
So we'll go for some problems on the thin cylinders. Okay. So what I noted last class, we got some derivations there. So just go through those derivations and we'll solve some problems on those derivations. Okay. That means those equations. Okay? So now, so you come across five main equations from last class. Okay, so that is what circumferential stress or hoop stress sigma c equal to PD divided by 2t. Okay, so PD divided by 2t. Next, longitudinal stress sigma L equal to PD divided by 4t. Then circumferential strain, so E1 equal to, so PD divided by 4TE in bracket 2 minus mu. Similarly, the longitudinal strain, so E2 equal to PD divided by 4TE in bracket 1 minus 2 mu. Next, volumetric strain EV equal to PD divided by 4TE in bracket 5 minus 4 mu. Okay, in bracket 5 minus 4 mu. Okay? So now we'll go for solving some problems on these thin cylinders. Okay? On these thin cylinders. So let us note down. Let us note down. A thin cylinder shell of 0.6 meters diameter and 0.9 meters long is subjected to an internal pressure of 1.2 Newton per mm square. Full point. The thickness of cylinder wall is 15 mm. Full point. Determine first the longitudinal stress, second circumferential stress, and maximum shear stress. Next, and change in dimensions. Okay? full point. Take V equal to, take E equal to 200 gigapascal. 200 gigapascal, and Poisson's ratio mu equal to 0.3. Poisson's ratio mu equal to 0.3. Right? Now, so first thing is you need to find out what is the longitudinal stress. Okay. Now, first you note down given data. Let us note down first given data. Okay. Now, diameter is given. Let us go for diameter D equal to 0.6 meter. Okay. This is equal to 600 mm. Okay. Next. So, length of cylinder is 0.9 meter here. This is how much? 900 mm. Okay. 900 mm. So, inside fluid pressure P is given. This is 1.2 Newton per mm square or 1.2 megapascal. Next, thickness of cylinder wall T is given. It is 15 mm. Okay. So next you need to find out what is the longitudinal stress. Okay. What is the circumferential stress? And what is the maximum shear stress? And change in dimensions. Right? Next, change in dimensions. Okay. Now, so we'll calculate first the longitudinal stress. Okay. We calculate first longitudinal stress. Okay. Let us go for a solution here. Longitudinal stress. Okay. Sigma L equal to PD divided by 2T. So now P is 1.2 Newton per mm square, diameter 600 mm divided by 2 into 15. So now you calculate what is the longitudinal stress. Okay. Next we calculate circumferential stress. Circumferential stress is sigma C equal to, sigma L is PD divided by 40.
40, sir.
Yes, 40, right. Okay. So now sigma C equal to PD divided by 2T. Okay. This is 1.2 into 600 divided by 2 into 15. So next it is what maximum shear stress in case of thick and thin cylinders. So now this is a ratio of sigma 1 minus sigma 2 by 2. Okay. Difference of sigma 1 minus sigma 2. So now in this case sigma 1 is what? It is sigma C and sigma 2 is sigma L. Okay. Sigma 2 is sigma L. Now we calculate what is the value of sigma L. How much?
Newton per mm square, sir.
12 Newton per mm square. Now this sigma C.
24.
Okay, 24 Newton per mm square. Okay. Next. So now we calculate the maximum shear stress. So what 24 minus 12 divided by 2 is 6 Newton per mm square. Right? So next you need to find out change in dimensions. Change in dimensions. Okay. So let us calculate change in dimensions. You need to find out what is the change in diameter. You need to find out what is the change in length as well as change in value. Okay. Right? Now, so if you remember the longitudinal strain equation, okay, what is the longitudinal strain equation? E2 equal to PD divided by 4,
Divide.
okay, 4TE in bracket 1 minus 2 mu. This is what longitudinal strain. Is it right?
1 minus
Right? Yes or no?
1 minus
Sir,
mu, sir.
1 minus 2.
Okay, longitudinal strain 1 minus 2 mu, it is right. Okay. Longitudinal strain E2. Okay. Next, circumferential strain. Circumferential strain E1 equal to PD divided by 4TE, okay, in bracket 2 minus mu. Check, right? Now you can easily substitute all values. Now every value has been given here, okay? Every value has been given. You can calculate the strains. You can calculate the strains. Is it right? Now let us calculate here first longitudinal strain here. P is 1.2, dia is 600, okay, divided by 4. Thickness is how much? 15 mm. Young's modulus is 200 into 10 to the power of 3 in bracket 1 minus 2 into 0.3. Okay, Poisson's ratio is 0.3. So now you calculate what is the strain in longitudinal direction. So now we calculate what is circumferential strain.
Twenty-four into 10 raised to minus 6.
Sigma EL, say that is sigma E2. 24 into 10 to the power of minus 6. Right. Now here, how much in this case? Whether it is 12, 1.2 into 600, okay, divided by 4 into 10 to the power of 5, sorry, 4 into 15 into 200 into 10 to the power of 3, and smallest value, in bracket 2 minus 0.3, it is in a bracket.
Sir, 102 into 10 raised to minus 6, sir.
102 into 10 raised to minus 6, right? Everyone got answer? 102 into 10 to the power of minus 6. Everyone got answer?
Yes, sir.
Sir.
Okay. Now you calculate the change in diameter. Okay. So now change in diameter. So delta D equal to E1 into D. Okay. E1 into D. Right. So strain equal to what? Circumferential strain is what? Delta D by D. Now you need to find out delta D. Delta D equal to what? E1 into D. Now E1 is 1.02 into 10 to the power of 102, right? So now it is 600. Now we calculate how much increase in the diameter, the change in diameter. I think it is 102 into 6, 7 or 612 12 612 into 10 to the power of minus 2 mm. Check it.
0.0
Point 0.0
0.0612.
0.2 mm. Okay. Next, so change in length delta L equal to E2 into L. Okay, E2 into L. So now you find out E2 is 24 into 10 to the power of minus 6. Okay, length is 900 mm.
Point 0.0216 mm, sir.
0.0216 mm. Okay. Now these are the changes in dimensions. Okay. So let us find out what is the change in volume here. So let us find out change in volume. So to get the change in volume, so you need a volumetric strain. Okay. Volumetric strain equal to what? Delta V by V. Now to calculate the volumetric strain, so you have noted formula for PD divided by 4TA. Okay. In bracket 5 minus 4 mu or 4 minus 5 mu.
5 minus 4 mu.
Okay, right. Substitute the values here. P is 1.2, diameter 600 mm divided by 4 into 15, 200 into 10 to the power of 3 in bracket 5 minus 4 into 0.3. Now you will get EV. Now you will get EV.
Two 28 into 10 raised to minus 6, sir.
228 into 10 to the power of minus 6. Right? Now you calculate change in volume. Okay, now we calculate change in volume. So change in volume delta V equal to, so EV into V. So EV is 228 into 10 to the power of minus 6. Okay, so volume is what? Pi by 4 into D square is 600 square into length. Okay, so now you find out change in value. Sorry, change in value, right? So how much you got change in value?
Sir, 5
Sir,
point
57987.5.
57
987.5.
987.5 mm cube. Okay. This is what change
Yes,
in
sir.
value. Okay. Okay, now the next one. A thin cylindrical shell. Okay, and now the next one. A thin cylindrical shell. Okay, 2 meter long, has 200 mm diameter and thickness of metal 10 mm, 10 mm. Full point. It is filled. It is filled completely with a fluid at atmospheric pressure. Atmospheric pressure. Full point. If an additional if an additional 25,000 mm cube 25,000 mm cube fluid is pumped in find the pressure developed pressure developed and hoop stress developed and hoop stress developed. Find also the changes in diameter and length. Full point. Take E equal to 2 into 10 to the power of 5 Newton per mm square and mu equal to 0.3. Okay. Now what they have given here? First, fluid pressure is at atmospheric pressure. Okay. If the fluid is at atmospheric pressure, is there any going to make changes in its dimensions? If fluid is at atmospheric pressure inside a cylinder, okay, is
No,
there
sir.
any going to make change in dimensions?
No, sir.
No.
No, sir.
Okay. Then they have pumped additional amount of fluid which has a volume of 25,000 mm3. How much? It's a volume of 25,000 mm3. Then it's going to create some stress as it is more than the required volume. As the volume increases inside the component, the pressure is going to get, right? So now you need to find out what is the pressure developed and what is the hoop stress developed. So how you can solve this one? Now they have given change in value. Okay, so they have given change in value. Okay, so now can you get the value of P based on change in value? Now if you look at the previous equation here, now this is what change in value. Okay, so to calculate change in value, what we have done? We have gone for 4, so PD divided by 4TE. Now by this equation, can you calculate the value of the P? By this equation, can we calculate P? Now change in volume is given. You can calculate volume, then you can calculate volumetric strain. Okay. So once you got the volumetric strain, I think you can calculate P here.
Yes, sir.
You can calculate P here. Now let us try this one. Okay, let us try first to calculate value of P. Once you got the value of P, you can calculate further things as easy. So first you note down all data properly. First you note down all data properly. Okay. So first you note down data. So have you noted? So length is L equal to 2000 mm. Okay. So diameter D equal to 200 mm. So thickness T is 10 mm. Next, so change in volume dV is 25,000 mm cube. Okay. So E is given 2 into 10 to the power of 5 Newton per mm square. Okay. So mu is given as a 0.3. Now we need to calculate. You need to calculate. So what is the pressure? Okay. And what is the hoop stress? That is about sigma C. And changes in diameter delta D and delta L. Okay. Delta L. So can you calculate? ನೀವೇ ಮಾಡ್ತೀರಾ ಏನು ಹೇಳಬೇಕಾ? Give answer. ಆನ್ಸರ್ ಮಾಡ್ರು ನೀವೇ ಮಾಡತ್ತೀರಾ?
Yes, sir.
Okay, we take 5 minutes and solve.
Sir, B 41,
How much?
41.89.
41.89. 41.89. You cross check. Somewhere I made a mistake.
Sir, 2.631 into 10 raised to 8 ಅಂತ ಬರತ್ತೆ sir.
Pressure.
ಹಾ.
No, somewhere I made it wrong. So first you calculate what is the value of volumetric strain EV. So volumetric strain EV equal to
So
what? Delta
minus
V by
398 into 10 raised to minus 6.
pardon
398.089 into 10 raised to minus 6, sir.
398 point
089 into 10 raised to minus 6.
this is volumetric strain. Yes.
Yes, sir.
Okay. Now equate this one to this formula. Now diameter is given, P, T, E, everything is given. Only one parameter is P here. Okay. So now this is what so P equal to, we rewrite equation, P equal to EV into T into 4 into E, okay, divided by D, okay, 5 minus 4 mu. So EV is 398 into 10 to the power of minus 6. Okay. So thickness T is 10 mm. 4 Young's modulus is 2 into 10 to the power of 5. 4 divided by, so diameter is 200 mm, right? So 5 minus 4 into 0.3. Someone calculate. Now 10 to the power of 5 minus here minus 1. Then you get here it is okay. Now 398. How much will get here? 398 into 4 into 2 divided by 200, 5 minus 1.2. How much you got?
$4.18.
4.18 Newton per mm square. This is the right answer.
I said that only.
41. 41, I think you said 41.
Power.
Power ಎಲ್ಲಿ ಕೇಳ್ತೋ ಪವರ್ ಎಲ್ಲಿ ಕೇಳ್ತಿ ಪ್ರೆಷರ್ ಗೆ ಪವರ್ ಐತಿಯಲ್ಲ huh? Okay, now how much you got pressure here? P equal to 4.18 Newton per mm square, right? Once you got the P, now we calculate all parameters again. So next what is what? Circumferential stress. So circumferential stress sigma C equal to, so PD divided by 2T. P is now it is a 4.18, D is 200, okay. So thickness is 10. So now we calculate how much you got.
$41.8.
41.8 Newton per mm square, right? Next, what they ask for the next? So hoop stress is over, pressure is over. Find the changes in dimensions. Okay. So let us go for change in diameter. Okay. To get the change in diameter, you need to find out E1. That is what epsilon 1 circumferential strain. Okay. So delta D you need to calculate here. Okay. So now circumferential strain equal to what? PD divided by 40E. Okay. In bracket. So 1 minus 2 mu. Now 4.18, diameter is 200. Okay. So 4 thickness is 10, Young's modulus is 2 into 10 to the power of 5. Okay. So 1 minus 2 into 0.3. Now we calculate how much we are going to get here.
Ten into 10 to the power minus 5.
Pardon? How much you got?
Sir, 4.18 into 10 raised to minus 5 ಅಂತ ಬರತ್ತೆ.
4.18 into 10 raised to minus 5. Okay. So next to find out change in diameter here. Okay. So change in diameter delta D equal to what? So E1 into D. So epsilon 1 is 4.18 into 10 to the power of minus 5 into 200.
$836, sir.
836 what?
Into 10 raised to minus 5.
Somewhere I made a mistake. Somewhere we made a mistake. You just calculate value of E1 here. 8.5 P divided by E. 8.5 E is 4.18 divided by 2 into 10 to the power of 5. How much you get here? Will get same.
Sir, pressure is 83.802, sir.
Pressure is
83.802, sir.
check it properly. No, by this equation you are going to get how much? Pressure. I removed it. Everyone got strain as 398.06 into 10 to the power of minus 6. Volumetric strain.
Yes, sir. Yes, sir.
No. So I'll rewrite 398 into 10 to the power
into
of
10 power minus 5.
minus 5, 6.
6.
Wait a minute. So EV equal to PD divided by 40E in bracket 5 minus 4 mu. Everyone got it? Okay. So now EV equal to delta V by V. I got 398 into 10 to the power of minus 6. Okay. Now rewrite for 398 into 10 to the power of minus 6 equal to P is unknown here. Okay. So D is 200 divided by 4. T is 10, E is 2 into 10 to the power of 5, in bracket 5 minus 4 into 0.3. So now someone calculate and give the answer here. P equal to 398 into 10 to the power of minus 6 into 4 into 10 into 2 into 10 to the power of 5 divided by 200 into 5 minus 1.2. Now we get a value of P. So you should get P equal to 4.18 Newton per mm square. Okay. Everyone got?
Yes, sir.
Yes, sir.
Then you check out why you made where you got a mistake in volumetric change in diameter.
L ಎಷ್ಟೈತೆ sir L?
L is 2 meter. Now what is the circumferential strain here? Circumferential strain. Okay. So E1 or epsilon 1 equal to PD divided by 40E in bracket 1 minus sorry, 2 minus mu is there, right? Okay. So now P is 4.18, diameter is 200, 4, thickness is 10 mm, okay? 2 minus 0.3. So first you find out E1 here. Someone calculate and give the answer. So how much you get?
So 17.76 into 10 raised to minus 5.
17.76 into 10 raised to minus 5.
Minus 5, sir.
Mhm. Just give one value here, you calculate how much you are going to get. Okay, E1 equal to 8.5 into 4.18 divided by 2 into 10 to the power of 5. How much you will get? Calculate here.
Sir, 17.7 into 10 to the power minus 5, sir.
You calculate this one. This
Same,
one.
sir.
8.5 into 4.18.
Same, sir.
Yes, sir.
17.76.
Same, sir.
Sir.
And if you multiply 200, okay, sorry. Right. Now you got strain here, right? You got strain, okay? Now you need to calculate change in diameter. So change in diameter delta D equal to what? E1 into D, okay? E1 into D. So now note down E1, it is 17.75 into 10 to the power of minus 5 into 200. Okay? So we will get, how much you will get? How much you will get?
3,553.
3000.
0.03, sir.
0.0355 mm. Okay. Now similarly calculate so change in length. Similarly calculate change in length, right? So you calculate what is the value of E2. Okay. This is equal to what? PD divided by 40E in bracket 2 minus mu. You will get strain here. Then delta L equal to what? L into E2. Okay.